Hey guys, I came across this really cool tile problem that you've got to check out. Hint, you can solve this in a bunch of different awesome ways. Each shape in the sequence is made up of black and white tiles, such that each shape has two more rows and columns than the one before it. How many black tiles are required to create the 15th shape in the sequence? If you're ready to have a go, pause me here, where I'll start to walk through a couple of fun solutions to the puzzle. 3, 2, 1. Of course, before we begin, we could just count out, physically, the 4th, 5th and 6th patterns and keep going until the 15th pattern. This would get us the answer, but it'd be quite time consuming, mathematically uninteresting, and we could run the very real risk of making too many mistakes. With that in mind, let's try to find a pattern between our first, second and third shapes given to us. From our first shape, it's quite easy to see we can surround this black tile with 4 black tiles in all the corners to get our second shape. To get from our first to our second shape, we add 4 black tiles. Equally, to get from our second to our third shape, we can find our second shape in the center here, and we add 8 tiles on the edges to get the third shape. This is add 8. From here, we must check the 4th shape to check if the addition relationship is add 4 each time, or indeed are we doubling the relationship? Are we adding 16 the next time? When we check out our 4th shape, we can construct this by drawing a box for our 3rd shape and adding the black tiles around it. When we do this, we find that we have an addition of 12 black tiles, which means the second difference each time for each of the tiles is 4. To get from 4 to 8, we add 4, and we keep this consistent throughout all the patterns. The next difference is an addition of 4, from 8 to 12. From here, what we could do is simulate this all the way to our 15th solution. This would be less time consuming than drawing them all out, as they're just numbers, but it's quite easy to see these numbers can get quite large and we can make addition mistakes again. Let's try to find something even better. We could at this point take our second difference, divide it by 2 to get 2, and have this as our coefficient on n squared to get a 2n squared quadratic solution to find our 15th term. But let's look at something more geometrically beautiful. From what we've already worked out, we can see our first, second, third and fourth, and therefore our 15th, are all squares in black and white tiles. Our first is a 1 by 1 square, our second is a 3 by 3, our third is a 5 by 5, and fourth is a 7 by 7. They're all odd numbers, and therefore we need to work out how big our square is going to be for our 15th pattern. Well, the term to term rule of odd numbers is just plus 2, and therefore the term to sequence rule is 2n minus 1. 2n minus 1 is our sequence, so we can sub 15 into here to work out our 15th square and how large that's going to be. 2 times 15 is 30, and 30 minus 1 is 29. So we're going to have a 29 by 29 square of black and white tiles for our 15th pattern. But the question was, how many black tiles are there? So we need to work out how many more black tiles than white tiles are there in every pattern. For the first, we have only 1 tile, and that tile is black. In the second tile, we have 9 tiles and 5 of them are black. In the third tile, we have 25 tiles and 13 of them black. Let's just rewind back to our second tile, and we have 4 white tiles. 5 black tiles, 4 white tiles. In the third one, we have 13 black tiles and 12 white tiles. And it's quite easy to see, given the relationship we've already worked out in our previous solution, each time we add 1 more black tile than the existing white tiles. So black tiles is the white tiles plus 1. So what we can do to 841, we can add 1 to it to get 842 and divide that by 2. 842 divided by 2 is 421. There are 421 black tiles and 420, one less, white tiles in our 15th shape. And therefore the answer to the solution, how many black tiles are needed to create the 15th shape, is 421. These are just two solutions to create the overall pattern and our solution, without having to spend excessive time drawing them out or indeed creating the actual 15th tile shape itself. With such mathematical patterns, there are always so many different cool ways to solve them. Let me know in the comments below which method you used to get to the answer. Thanks for watching Beat the Calculator. See you next time for more logic and maths fun.